This video is for November 16th and November 17th. We're looking at continuing to use the fundamental trig identities to simplify expressions. Specifically here, we're looking at how we can do some things with fractions as well as factor expressions and how that might help us simplify. So in this first one, I'm going to do 3 on this video, talk through some of the strategies, and then I'll post the other solutions online. But here in this first problem, in class we talked about what we noticed and how we can possibly simplify here. And some students said, well, we'll have sine x here and sine x here. We're subtracting, so those would go away. Not the case because we don't have like terms. This sine x is being multiplied by cosine squared, so we can't subtract them because we don't have like terms. However, but what I mean by terms are quantities separated by addition or subtraction. So this would be one term, this would be a second term. However, in both terms, we do have sine x. So I have sine x here, sine x there in each term. This is what we did, what we've been doing on warm-ups comes in handy because we have a quantity in each term. That means we can factor that quantity out. So I can put that quantity there, factor it out. Now if I factor out sine of x, here, now I open parentheses and I write basically what we would have left. Here I had sine x cosine squared, I factored sine x out, so what we would be left with is cosine squared x. Here I had sine x, I factored sine x out, and if we factor everything out from a term, we're left with 1 because we're really doing a division here. We're dividing the sine x, replacing that, dividing sine x by sine x to get 1. If you ever need to check, you always could by distributing. So what we're really doing when we're factoring is reversing the distributive property. Here, if I took sine x and multiplied by cosine squared, sine times cosine squared, that would give me the first term. Sine times 1, that would give me the second term. So we know that we did factor correctly here. And that is a strategy, huge thing here, the factoring, something that we'll need to use moving forward. If we see a quantity in both terms, we need to understand that we can factor that term out or that quantity out from each term to help us simplify different expressions. But now here we have cosine squared and 1. Anytime we see something squared and 1 with our trig functions, our eyes should immediately go to Pythagorean identities. The one that deals with cosine squared and 1 is this guy. And the idea is that we're trying to get cosine squared minus 1 on one side of this identity. Here we want the 1 to be negative, so if we subtract 1 here and there, then we'd be left with 0. Sine squared plus cosine squared minus 1. So I have cosine squared minus 1 here, but I want to isolate it so I can replace it in the expression here. So we can isolate that by subtracting sine squared from both sides. Those go away. Okay, so we have cosine squared minus 1 here. It's equal to negative sine squared. So what we can do is replace this cosine squared minus 1 with negative sine squared x. This sine x stays there. And if we wanted to multiply sine times negative sine squared, that would give us negative sine cubed x. So 2 big things in this problem. First is, factoring out the sine so that we have an expression that we can deal with using the Pythagorean identity, and then actually using the Pythagorean identity to substitute the cosine squared minus 1 with negative sine squared and ultimately end up with negative sine cubed. Okay, so the factoring piece, that's a huge strategy that we're going to need to use. And there are other problems within this these guided notes that have the factoring to help us simplify different expressions. Let's go on to the next one, different strategy. Here we're dealing with, I'm going to split this up. Here we're dealing with fractions, so we're going to talk about a strategy in a second. But first we have, again, cosecant squared and minus 1. Something squared minus 1. We should look at the Pythagorean identities. The one that deals with cosecant squared and 1. That's this one, 1 plus cotangent squared x equals cosecant squared. So if I want to get cosecant squared minus 1 on one side, the 1 wants to be negative, so we can subtract 1 from both sides. And so cosecant squared minus 1, that's equal to cotangent squared. So here in our numerator, I can replace that with cotangent squared. Okay. Now, a strategy here that is really helpful. We can always rewrite division as multiplication. So this over is essentially just division. So we're really doing cotangent squared divided by cosine squared. If it helps you to actually write it out, you could actually write it out like this. If it helps. Maybe it doesn't help, but maybe it also helps you see it. Now we're dividing by cosine squared. I want to turn this to multiplication. Well, I know that I can turn division into multiplication if I multiply by the reciprocal. Really, this is cosine squared over 1, which means I can multiply this by 1 over cosine squared. We could have done that straight from here as well. If I divide by cosine squared, I can also multiply by 1 over cosine squared. All of this is equivalent. A strategy that's really helpful. Maybe this helps you think of it, maybe going straight from the division to the multiplication. Maybe that helps as well. Either way, the idea is we can write division as multiplication. And now, why is that helpful? Well, now we know cotangent. We can replace cotangent with cotangent squared with cosine squared over sine squared. Let's multiply straight across. Cosine squared times 1 would give us cosine squared. Sine squared times cosine squared would just give us sine squared cosine squared. The cosines would divide out, so we're left with 1 over sine squared, which just gives us cosecant squared. So this is the idea here, so that we can write division, either write it as division here and then ultimately multiplication, or go straight from division to multiplication. That's a huge strategy that's going to be helpful, because once we do that, then we can write it. Hopefully, when we rewrite it, things would divide out, help us simplify to get to our solution here of cosecant squared. I'm going to stop this video here, show one more problem in the next video, and then post all the solutions online. If you have questions, please ask, or you need to rewind, whatever is going to help you. Please make sure you get, if you have questions, get those answered through the Remind app, in person, email, whatever helps you.